Welcome to The Explainer. Today, we're going to pull back the curtain on something that's a huge deal in AI. How do we give it a memory? We're talking about transforming those forgetful digital assistants into partners that actually know you.
All right, so let's just dive right in with a question that I'm sure has bugged a lot of us. You know how you can have this amazing, super detailed conversation with one of these powerful AIs, but then the very next time you chat, it's like you're total strangers. It has no idea who you are. So what's going on there?
Well, the answer is actually pretty simple. It's because these large language models, LLMs for short, are what we call stateless. And that's just a fancy way of saying that outside of the one single conversation you're having right now, they have zero built-in memory. None. Every single time you start a new chat, it's a completely blank slate.
So, okay, that's the problem. How in the world do we fix it? Well, the solution is to, intentionally give the AI a memory. And there's a whole discipline dedicated to making this happen. It's called context engineering.
And honestly, the best way to get your head around this is with an analogy from the kitchen. Think about how a great chef works. They do their mise en place. That's that crucial step of getting every single ingredient chopped, measured, and laid out before they even turn on the stove. See, with an AI, you're not just handing it a recipe or a prompt. You're setting up the entire workstation with all the right ingredients, the right tools, everything it needs to nail the final dish. And that right there, that really gets to the heart of it. Context engineering is so much more than just writing a good prompt. It's this whole process of dynamically pulling together everything the AI needs to know for this one specific moment. Your past conversations, important facts about you, special instructions, data from other sources, and then packaging it all up perfectly for every single interaction.
Okay, so let's get a little more practical. How does this actually work? Well, this whole process really leans on two key components that work together. And you can think of them like a workbench and a filing cabinet.
So you've got your immediate, active workspace for whatever you're doing right now. And then you've got your organized long-term storage for all the really important stuff you need to keep. So first, let's talk about the workbench. Just picture it in your mind. It's kind of cluttered, right? It's got all your notes, your tools, your reference materials spread out everywhere. Everybody's right at your fingertips, which is great, but it's also temporary. It's messy, and it's set up just for the one project you're working on right now.
Okay, so in the AI world, that workbench, that's what we call a session. It's basically the container that holds the entire chronological history of one single conversation. And just like a real workbench, once that conversation is over, poof, the whole thing gets cleared off. But now, think about what you do when the project is finished. You don't just take that entire messy workbench and cram it into a closet, right? No way. You sift through it, you find the really important documents, the key takeaways, and you file them away neatly in an organized filing cabinet. You guessed it, that filing cabinet, that's the AI's memory. This is the magic part. This is where the crucial bits of information, things like your personal preferences or key facts from conversations you had weeks ago, get captured, consolidated, and stored for the long haul. This is what creates that persistent, continuous experience that carries over from one chat to the next.
Now, I know what some of you might be thinking, especially if you're deep in the AI space. This sounds a whole lot like retrieval augmented generation, or RAG, right? And you're not wrong. They're definitely related. But, and this is a big but, they serve two fundamentally different purposes. And the source material for this explainer has an absolutely perfect analogy for this. Think of RAG as a research librarian. She's an expert on facts about the world. She knows everything in the library. Memory, on the other hand, is your personal assistant. He's an expert on one thing, you. See, the librarian goes and pulls information from a huge shared library of public factual documents. It's mostly static stuff. But the personal assistant, he keeps a private, totally dynamic notebook just for you. It's constantly being updated with your personal history, what you like, what you don't like, your goals, all of it. So if there's one thing to take away from this comparison, it's this. RAG makes an agent an expert on the world. Memory makes an agent an expert on the user. And here's the kicker. To build a truly great, really intelligent agent, you absolutely need both. Okay, so this all sounds great in theory, but how does an AI actually make and keep these long-term memories? Well, it's not just magic. It's actually a pretty sophisticated automated pipeline.
So it's basically an LLM-powered process that happens in four main steps. First, it sucks in all the raw data, let's say the transcript of our conversation. Then it uses an LLM to smartly extract the really meaningful bits of information. Now, step three is the most important part, consolidation. This is where it compares the new info with memories it already has to get rid of duplicates or fix any contradictions. And finally, that new, polished memory gets stored away for next time.
And this idea of being a diligent gardener is just a fantastic way to think about why that consolidation step is so critical. You see, it's not just about piling on more and more information. That would just be a mess. It's about constantly tending to the garden, pulling out the weeds, pruning back things that are no longer relevant, to make sure the AI's memory stays healthy, organized, and actually useful. All right, let's zoom out and bring this all home. Why does any of this matter? What does it actually mean for us when we start building agents that can truly remember? This is where it gets really exciting. Well, when we use context engineering to combine that temporary workbench of a session with the long-term filing cabinet of memory, we finally unlock the ability to build AIs that get us. AIs that offer deep personalization. They can handle super long, complex projects or conversations without losing the thread. And, this is the big one, they can actually learn and adapt over time. They build a continuous, evolving relationship with you, the user. And that leaves us with a really fascinating, kind of profound question for the future. As we get better and better at building these systems with perfect, crystal clear memory, the big challenge is going to shift. It won't just be about remembering, it'll be about knowing what to forget. How do we teach an AI to proactively let go of old, irrelevant, or outdated information to make sure its memory isn't just huge, but wise? Now that is the next frontier.